Good evening, everyone. Welcome to our geography session. Today we'll start with a new topic, that is heat budget of the Earth. Okay, heat budget of the Earth. I think in last class I gave you a brief introduction. I was telling like whatever energy coming from sun towards the Earth, or whatever incoming solar radiation coming to the Earth will not keep it as a body, and it will reflect it back as long wave radiation or terrestrial radiation. By this time, you should be knowing this. Okay. So, Earth as a whole body does not accumulate or lose heat. It maintains its temperature, and this happens only if the amount of heat received in the form of insolation equals the amount losing from the Earth. That means whatever is coming have to be equal to whatever is going out. Earth have a temperature, it maintains that, and there is no effect of energy coming from sun towards the Earth. Okay, we may get affected because we are on top of the, or we are on the surface of that Earth, touching the atmosphere. We are there, or the biocycle is there. Our Earth as a body, it will not accumulate or lose any heat. It maintains its temperature, and whatever heat received in the form of insolation, that is incoming solar radiation, equals to the amount lost by the Earth through terrestrial radiation. Okay, that is what we discussed. So I'll give you a picture. You can draw this picture with me, and this will give you an exact or clear-cut idea about what is the heat budget of the Earth. Okay, suppose if this is Earth. Earth as a body, okay, we have incoming solar radiation, sun, from sun, okay. Suppose whatever incoming solar radiation is coming, if 100% is coming from the sun towards the Earth, we imagine, and this is our atmosphere, we live here, we live here, correct? Okay, so whatever 100% is coming in, I told you there is something called albedo of the Earth. Albedo of the Earth. Albedo means reflection from the Earth's surface, mainly from white colored surfaces like snow, clouds, or ice, and all these things is called the albedo of the Earth. Okay, the reflected amount of radiation is called the albedo. Okay, and this actually will be from snow on ice covered areas of the Earth. So when I'm talking about albedo of the Earth, if 100% energy is coming from sun to, what are we trying to prove here? I am trying to prove here that whatever incoming solar radiation or insolation is equal to whatever going from Earth. That means whatever coming in is equal to going out, and Earth as a body will not keep any energy with it. Okay, we are going to prove that. Okay, fine. So I'm telling albedo is there because same radiation, it is not processed, incoming only, it is going. Suppose 35% is gone out as albedo. So what is left? 65% is less. In among 65%, whatever absorbed by atmosphere is 14%. Okay, I'll repeat. 100% was coming to the atmosphere from the sun. Albedo of the Earth is 35%. That means 35% of the energy is reflected back on the way itself. Okay, maybe it reaches a surface, maybe it is not reaching from the cloud itself, it is reflected back, or sometimes it is reaching the Earth's surface, then it is reflecting back. Anyway, albedo exists, and 35% we are calculating that it is reflected back. Okay, rest we have only 65%. From 65%, 14% is absorbed by atmosphere. Okay, now what is left? Only 51% is left. Okay, now we have to prove that whatever 100% have come in, only 50%, 51% have absorbed by the Earth or reached Earth, and this 51% is what we are radiating out from the Earth, and therefore whatever incoming is equal to whatever outgoing. Okay, and how do we prove this? Because outgoing, what is outgoing? Terrestrial long wave radiation is going out, correct? When this is outgoing, and this is like 34% absorbed by atmosphere, and rest 17% by space. Okay, you don't have to remember any of these numbers, nothing. Only you have to remember that approximately 51% come in, and 51% goes out. This is the heat budget of the earth. Okay, you don't have to remember about any number, but you should be having a fair enough idea about what is happening with the heat budget of the earth. What is heat budget of the earth? Okay, considering that insolation received at the top of the atmosphere is 100%, after 35% albedo going on, then after atmosphere absorbing around 14%, we are getting on 51%. 51% is reflected out also. Okay, and this is called the heat budget of the earth, including the albedo of the earth. Okay, I hope this is clear. This is a very simple concept. We just wanted to prove here that whatever incoming is equal to whatever outgoing, and earth as a body is not maintaining any energy with it. Okay, you can expect prelims question or statement based question asking that earth is absorbing this, or what is the source of heat in the earth as a body. If earth as a body and there is some heat inside the body, so what is the source? Don't get confused thinking that the source is the sun. Sun is not the source. Earth itself has some radioactive process happening inside the earth, and that's the source of heat as a body. It is independent. Okay, and from sun whatever is coming, it is going out. Okay, who is benefited? We are benefited because we are getting whatever energy from the sun. Okay, that's a simple logic. 100, considering 100% coming in, 35% is albedo, it is gone. 14% is absorbed by atmosphere. Rest only 51% is reaching on the surface, or what we are getting. We are human beings or life getting only 51% is what I mean. And we are reflecting back 51%. 100% is coming from sun, but by the time it reaches the atmosphere, only 51% is reaching. Rest is lost on the way. Okay? Okay, fine. Let us continue. Yesterday I told you I will discuss also about factors controlling temperature distribution in a place. Okay, little bit idea you have, but I would like to discuss little more. Okay, so for further clarity, factors controlling temperature distribution. Factors controlling temperature distribution. Let us try to understand what are the different factors that are controlling the temperature distribution in the earth. Okay, so temperature of temperature of air actually at any place is influenced by different factors, or temperature what we feel as a human being or living organisms or anything on the earth surface is what we feel in today. What we feel here now in India is different from what people feel in Canada. There's different. Okay, what Canadians feel is different from what Australians feel. Correct. So why there's a difference? Okay, because considering that sun is at a definite specific distance from earth as a body, we are like spherical in shape and we are all at the same place. And why there's a difference in the heat? Why people on the entire earth is not receiving same heat? Okay, that is what we are trying to see here. So there are different factors that control temperature distribution. First factor is latitude of the place. Okay, yesterday I have given you little information. This equator, Tropic of Cancer north, Tropic of Capricorn south, north. Okay, suppose if Canada is there, Australia is here, both the countries are in two different latitudes, right? Because of that, whatever sun's rays is coming, because of that, whatever sun's rays are coming, it is falling differently. What he will feel and what he will feel is different. Okay, so depending upon which latitude you are living, the distribution of temperature or heat will vary. Okay, second one is altitude of the place. You can keep writing with me. Altitude of the place. What do you mean by altitude of the place? Altitude of the place means how in height you are there. Okay, for example, you are on top of Himalayas. Okay, and I am in the valleys in Bihar, for suppose. Okay, and you are on top of Himalayas, almost in the territorial extent of Nepal if you are there, and I am in the valleys of Bihar. What I will feel and what you will feel, the temperature is different. Okay, what is differentiating here? The altitude, the height. That also makes a lot of difference. Okay. One more thing you have to remember, that don't get confused thinking that sun is here because on the top of a hill you will get heated more. No, that is not the ideology. You will get heated less. You will get less temperature. The ideology is that heat is coming from the earth's surface, not from sun. What we feel, the source of energy is from the earth's surface and not directly from the sun. So when you're, for example, any hill station you are going, Mount Abu or anywhere you're going, you're standing on top of the hill, you are supposed to get lesser temperature comparing to the plains down. Why? Because you are a little far away from the surface of the earth because of the top of the mountain. Okay, so all these things actually determines the altitude. So altitude of a place also differentiates the temperature distribution. Third one is distance from sea. Distance from sea. See, distance from sea is another factor that influences the temperature. See, compared to land, I've told you yesterday, sea gets heated slowly or land gets heated very fast. I told you, land as a body will get very fast, quickly get heated. Sea will get heated very, very slowly. I told yesterday, I explained to what's the reason also. Okay, so land gets heated up and cools down, and at the same time, which one will get cooled also very quickly? Land will get cooled, heated up, and cools down also very quickly. Therefore, the variation in temperature over the sea is less compared to land. The places situated near the sea come under the moderating influence of the sea and land breezes which moderate the temperature. Because of that, we can say that distance from the sea is also a factor which is actually contributing to the temperature difference. Okay, for example, if you live in coastal areas, okay, India have like this. If you live in any of these coastal areas from Gujarat to West Bengal, any part if you're living in, you will always feel a moderate temperature. You will not feel the extremes of temperature, either too cold or too hot, you will not experience, correct? And if you are in the middle of the country or central part, or where you are not surrounded by, not near to any of the water bodies, you will feel extremes of temperature. You feel extreme hot in summer, you feel extreme chilled winter during the winter time. Okay, so that's a difference. So sea is playing a major role. How sea is playing? Sea is playing through two different factors: land breeze and sea breeze. Okay, that's two different factors that we can explain later if we get time. But you have to understand now for time being that presence of sea also influencing the temperature of a place. Okay. Let's continue the fourth factor. Fourth factor is presence of warm and cold ocean currents. Presence of warm and cold ocean currents. Okay, so what is this? You know what is ocean currents? Ocean currents are actually moving water in the ocean is called ocean currents. It's moving with the influence of different factors like gravity of the earth, centripetal force, because of the movement of wind, Coriolis force. There are a lot of factors that is influencing the movement of ocean current. That's a very different thing. But I want to emphasize here saying that the ocean currents also presence of which kind of ocean current. The ocean current is it is hot ocean current, or it is warm ocean current, or cold ocean current. Depending upon that, what temperature you feel is different. Okay, so see, places located near the coast we discuss now, where the warm ocean current is passing. Suppose you are in the coast here, and if it warm ocean current is passing, then you will feel hot. Okay, and for suppose here, if you are here and eastern side, if cold current is passing, that means whatever water flowing is cold. Okay, if cold current is there, then what temperature you will feel here? You will feel cold temperature here. Okay, that is what we intend to say here. Presence of ocean currents, depending upon what kind of ocean currents present where, that also emphasize the how you feel about the temperature. Okay, I hope this is clear. Next one is, okay, that's it. Then we can also talk about local aspects. If a presence of dam is there, or some water bodies nearby to your house, that also have an influence. Local aspects are also there. Okay, this is about the different factors controlling temperature distribution. So what are the factors? We have latitude of the place, altitude of the place, distance from the sea, presence of warm and cold ocean currents, and local aspects. See, air mass. Air mass is actually, if suppose somebody is asking me a doubt about air mass, that is why I'm explaining here. What do you mean by air mass? Air mass is actually a body. 1 minute. Let me take a new slide. Okay. Suppose this is the Earth's surface. Okay. And a column of air up to a certain kilometers. Okay. It can be 80 to it can be 100 kilometers. And this column of air, we call it as an air mass. Okay. What's the peculiarity of an air mass? How can you say this is an air mass? Because whatever molecules are here, they will have the same properties. For example, if the air mass is cold, all the molecules will be cold. If the air mass is hot, it will be hot. So we can say it as a hot air mass or a cold air mass. It's a column of air. Okay. It can be 80 to 100 kilometers width. Okay. And they all exhibiting the same properties. So this air mass also actually affect the ocean currents. Okay. The places which comes under the influence, of course, it affects the temperature. Okay. So I didn't speak about this because I already spoken about ocean currents. So this is the same logic. Okay. See, the places which comes under the influence of warm air mass. If you have warm air mass, for example, you are living here. Okay. We all are living here. India as a country is here. Considering that we all are in India and we are living here. If it is December, what will you feel? And we will have cold air mass and we'll feel chill. Correct. And if somewhere in April or May, hot air mass will be present, considering 80 to 200 kilometers if you are in one place, and that also affects the temperature. So, like how I told you, the land and sea breezes, the passage of air masses also affect the temperature. The places which comes under the influence of warm air masses experience higher temperature, and the places that come under the influence of cold air mass experiences low temperature or chill. Okay, that is the ideology about the air mass influence. Okay, you can write this also as a factor, not a problem. Okay. Next, we'll discuss about inversion of temperature. Okay, inversion of temperature. Inversion of temperature. What do you mean by inversion of temperature? If there is top and down portion will go up, top portion will come down. That is a simple English meaning of inversion of temperature. Okay, you should be having this idea in your mind when you are thinking about what is inversion of temperature. Okay, now listen to me. Normally, temperature decreases with increase in height. That we know. Okay, I told you when temperature will decrease, at least in troposphere, we are sure that because stratosphere, ozone layer is there. Thermosphere, ionosphere is there, differentiation exceptions are there. But normally on the Earth's surface, when you go up, what will happen? Increase in height. When you go up, temperature will decrease. Okay, why? Because there's something called normal lapse rate. Okay, normal lapse rate. See, what is normal lapse rate? Because every 1,000 meters you go or every 1 kilometer you go up, temperature will decrease by 6.5 degrees Celsius. Okay, you don't have to remember anything. I'm just telling you a calculation. Just only you have to remember that when you go up, temperature decreases. It is called normal lapse rate. So at times, the situation is reversed. And this normal lapse rate is inverted. And it is called inversion of temperature. Basically, what has happened is that at times, what will happen when you're going up, temperature is increasing. That will happen. A down part will be cold and upper part will be hot. That will also happen. And this situation is called inversion of temperature. See, normally this will not stay for a very long time. It is actually for a very short duration, but quite common nonetheless. Okay. A long winter night with clear skies, still air, clean air, still situations. All this is an ideal situation for inversion. So inversion can happen in a long winter night when skies are clear, when air is clear. That means it is actually facilitated for the movement of air. Okay. Actually, for example, if there are two mountains, considering two mountains are here. and on the top there will be cold air, correct? Because surface of the earth source is from here, correct? Heat source is from here. So cold air will be there, hot air will be there. What will happen at night when if the winter night is so long and if night is clear, what will happen is that I'm telling an example. This is a way that inversion of temperature can happen. There are different reasons that it can happen, but I'm telling you one thing, okay? So the inversion takes place in hills and mountains due to air drainage. I'll tell you, okay? See, cold air at the hill on top of the mountain during the night flows down slowly. It will come down. Okay. Why it is coming down? Because of the influence of gravity. General knowledge. Okay. Influence of gravity, it is coming down. So being very heavy and dense, this cold air acts almost like what? Water and moves down the slope and it will pile up here. So what is the temperature here now? It become cold. Okay. And this process called air drainage, and this is actually an example of inversion of temperature. Okay, this is only an example I'm telling you. See, you have to remember these things in mind. Inversion of temperature means normally when you go in the atmosphere with the increase in height or altitude, there's a decrease in temperature. It is becoming colder when you go up. Simple thing. What happens at times, the situation will go ulta or changes, and what happens is that the cold air will come down and the hot air will go up. Something like stable and unstable air we discussed. You remember? I hope you remember. So, like stable situation, cold air is down and hot air is on top. That happens, and that is called the inversion of temperature. Okay. I hope this is clear. It's very small concept, but if a question comes, then you should be like some idea have to be there. What is inversion of air? Okay, now we'll go to an entirely different topic. Today being the last day, I want to take you to a different topic also. Okay. I want to discuss about oceans. Okay. Let's discuss about oceans. Oceans and continents. Okay. Oceans and continents we'll discuss today. So why we are discussing this? Because almost in the atmospheric concept, we have touched all the part. Okay. Small things also we have covered, like stable, unstable, inversion, and all these things. So you guys should be having a idea about what it is. And of course, reading of NCRT, revising NCRT multiple times, especially class 11, it is a mandatory thing. Okay, before you sitting for prelims, before you sitting for not prelims, actually the test series, whatever you are going to write down, make sure that you revise class 11 NCRT thoroughly, minimum 3-4 times. Okay, see, it is very difficult to understand things on a first reading or a second reading. Okay, you have to read it multiple times to get the notch. And once you get the thing, and I told you yesterday also, once you understand the concept in geography, you half the work is done. Now only you have to remember small jargons or statements. Okay, fine. So distribution of oceans and continents is, see, class 12th NCRT, it is actually optional. If you want, you can read, but that input-output ratio, if you are seeing, it is not that much. But because don't avoid it, maybe once or twice you can read it and keep it. Plus, class 11 is a must thing. Okay, both fundamentals of physical geography and Indian geography is also there. Another book, 2 books are there. Both the books are a must. Okay, there is nothing you can compromise on this. Okay, so that have to be covered well. See, current affairs and geography, again, you have to think twice before you take that approach. Okay, if you are seeing only current affairs, the trend in UPSC is that they're asking conventional part also with regards to history, geography, and all. It is not related to current affairs. Yes, whatever covering in current affairs, give an extra emphasis. For example, some cyclone is happening, give an extra emphasis on how cyclone is forming and all these things. That have to be there as a normal aspirant. But the conventional things have to be clear. See, there are some basic aspects in all the subjects. be it history, geography, economics, ecology and environment, whatever topics we are taking. Okay, all these topics whatever we are taking, there are some basic understanding or knowledgeable things is there that have to be clear cut in your mind. Okay, what will I say? The ideology of each of the things have to be very, very clear. Then you can build up on these things. Okay, how will you get the ideology? How will you get the base or the conceptual clarity? Through NCRTs. Okay, you cover NCRTs, you get the idea, get the starting point, make the foundation correct, then you go for higher level books. Of course, you will get questions from higher level books. I'm not saying only depend upon NCRT for all the subjects. There are exceptions. Geography, I know it is okay, but history and all, economics, for example, purely depending upon NCRT will not fetch you that mark. Okay, you have to make the foundation and move to higher books. But provided that foundation have to be strong, you cannot build a building when the foundation is very weak, right? So that is the concept. Okay, and everything covering. See, last year when you're seeing current affairs proportion is very less. Okay, only in science and tech and other areas, current affairs emphasis was more. Otherwise, we can see there's a lowering trend of current affairs. But we cannot imagine next year they may ask. So I'm not saying that reduce the study time, but keep a balance between the two. You should be having conceptual clarity in all the subjects which you are studying, basic minimum understanding. Okay, because everybody is reading same book, everybody is reading the same content, so you cannot compromise on that. A person sitting next to you and studying also reading the same book, so whatever he should or she should be answering, you should also in a situation to answer. There's no compromise on that. Then you build upon that. It is your wish. Okay, fine. We'll discuss about oceans and continents now. First, I'll discuss about continental drift theory. Continental drift theory. See, even though we call it as a theory, all these things are actually phenomena or things that has happened on the in the earth. Okay, so all these things are very interesting to know that okay, all these things happened and we at this time evolved, or we are in India, or we are in this place, we are on standing on the Indian plate after so long, journey was so long, lots of up and down was there. All these things, it is very interesting to know. Okay, if geography was like this. Okay, you can take in that sense. Please don't study as if you're studying a theory. It will be boring. Understand that okay, all these things happen with a curious mind. Okay, it will help you. Fine. What is continental drift? See, when you are seeing the world map, you can see very clearly that some places it is like jigsaw puzzle. You can match it some continents. For example, South America and Africa, you can match it. North America and western part of Asia, you can match it. Okay, so it is like jigsaw puzzle, something like that. Okay, so obviously people in the earlier time also, they were very curious to see okay, how come this has happened and there is something behind this. Therefore, people started studying all these things. Many scientists have done many work on that, but we are talking today with respect to continental drift theory, and I would like to talk about Alfred Wegener here. Okay, a thinker or the scientist, geologist, we can say, okay, or a meteorologist. Okay, he was a German person, so we can say it as German meteorologist. Okay, Alfred Wegener. See, some things I tell you, it is not in spite of on the point of exam, but a general understanding. Okay. Alfred Wegener was the person who propounded the theory of continental drift theory. He said that, okay, he proposed this in 1912. Okay, not important, but I'm telling you. Okay, he said that, okay, seeing the world map, it is very curious to understand that all this like a jigsaw puzzle. So there is something behind this, and he have done some understanding, and he came to the world and he presented that. Some people accepted, some people did not accept, and when later on we have developed, other scientists come and we have developed and but anyway, there are some points that actually true. We also feel that, so we'll discuss about that. Okay, so Alfred Wegener said that the continents, actually there was some time before there was only one land and one ocean. Okay, now we have 7 continents and 5-6 oceans. Okay, now it is not like that. Okay. Now what's the current situation? Current situation, we have North America. Excuse me for my drawing. Okay. We have South America. Okay. We have Asia. We have Europe here. Okay. And we have South Africa, sorry, Africa. It's always like South Africa, I say Africa. We have Australia. Okay. We have Arctic area, Antarctic area. It's a rough sketch of a world map, how it looks like, correct? So, and we have different oceans here. We have Arctic Ocean here. Arctic Ocean. Okay. We have, which ocean is between these two? We have Atlantic Ocean, North Atlantic Ocean, South Atlantic Ocean. We have North Pacific Ocean, South Pacific Ocean. Here also this continuation. Okay. This side is actually this side. I hope you got my point. Okay. Pacific, and we have Indian Ocean here. Okay. And we'll be here. We are here. Okay. This is a rough sketch. So seeing this rough sketch, Alfred Wegener have pointed out certain things saying that no, it was not like this before. And now also it is changing. Okay. After few millions of years, after something, if you're seeing, the world map will not be looking at the same position. The quadrants will not be the same. It will be moving. And now also it is moving. And he have pointed out certain things. Okay. That we'll see. Okay. He said that all the continents formed a single continental mass and a mega ocean surrounding the same. Okay. This continent or this mass of land was called Pangaea and the mega ocean was called Panthalassa. Okay. I'll note down. It was like this. Mega ocean was there. Okay. And there was a land mass. And this land was called Pangaea and this mega ocean was called Panthalassa. Okay, that is what he said first. Okay, and he said that around 200 million years ago, the supercontinent Pangaea began to split. It started separating. Okay, began to split, and what happens is that it divided into two continents called Gondwana and Laurasia. Okay, northern Laurasia. Excuse me for my writing. Laurasia. See, every class I take a walk thinking that from next class onwards I'll write well and then it goes on like this. Sorry. Laurasia and then Gondwana. Gondwana land. Okay, this is land. Okay, Laurasia land, Gondwana land. Okay, that is what after some time, after 200 years or something, it become like that. Okay, then again it broke into different. So Laurasia broke into North America, Europe, Asia. Gondwana broke into South America, then Africa, Australia. So all these divisions have happened. That is also the idea what he gave first. Okay, so this is the concept. I'll repeat again. Alfred Wegener in the year 1912 came up with a concept called continental drift theory. In this theory, he said very clearly that there was a big mass continent called Pangaea and there was a mega ocean called Panthalassa. Okay, around 200 years ago, the supercontinent Pangaea began to split. Pangaea first broke into two larger continental masses known as Laurasia and Gondwana. Laurasia towards northern hemisphere, Gondwana towards southern hemisphere. Subsequent Laurasia and Gondwana land continued to break even into very small continents that exist today. So a variety of evidence was offered to support all these things. So we'll see what are the evidences or what are the points which he said to support his argument. Okay, what were the points? First one. Same thing, what I was saying, matching of continents. Matching of continents. See, if you're seeing rocks of same age, correct. See, Africa was like this, and America was like this, something like this. So it could fit here. That is what we need to say, matching of continents, or we can say also like jigsaw fit. Yes, contribution of minerals also. Okay. So what is the matching of this continent or jigsaw fit? See, shorelines of Africa and South America, I told you, they could match here. Okay. And see, nowadays, if you're seeing, you can program all this in a computer. You can give the input and you will get the output. That time, it was not that scientifically updated. The world was not that scientifically updated. So we have mostly used with the paper concept, print concept, but yes, it was right. Okay. Second one was rocks of same age across the ocean. Rocks of same age. What to find here, what to find here, and what to find here, it is same age. Okay. So radiometric dating methods are used to understand this age of the rocks. For example, Brazil. See, so if North South America you are taking, you have Brazil here, Brazil, and Western Africa we have Sahara and all these areas are there. If you're taking rocks from same places, it is like almost at the same age. Okay. Then we have something called tillite deposits. Tillite deposits. What are tillite deposits? It's a sedimentary rock actually formed out of deposits of glaciers. Okay. Now we know, you look at this. Look at this. You know that if normal understanding, if you are thinking that no, it was there from the starting onwards, the picture of world was like this, then there are many things just contradicting this argument. Okay, for example, from Africa, from India, from Australia, many places we have got glacier deposits or tillite deposits of sedimentary rock. So if it was like this before, the question was same, then how come glacier deposits are there? Okay, so we have come to a like unambiguous evidence of paleoclimates and also drifting of continents, saying that no, it was there before together and later on it was spread. That is why the deposits are of the same thing. Okay, see the Gondwana land system of sediments from India, it actually found in 6 different land masses of the southern hemisphere itself. Okay, like Africa, Falkland Islands, Madagascar, Antarctica, Australia, New Zealand, all these places we could find whatever we could find in India. So that's like a bigger thing. Okay, so we can just say that it was all together before and later it got divided in different parts. Okay. Fourth one is placer deposits. Placer deposits. See, for example, we can see the occurrence of gold in Ghana coast and the absolute absence of rock in this region. Okay, we can see here we have Ghana. There is a country called Ghana, and we found gold from here. But the source of gold was not here. Where was source? Source was there in South America. Source was here. Source was here, and the product was here. Okay, so you imagine it was together before and later it got separated, and we are getting the output now. Okay, so that's a placer deposit concept. Okay, I hope whatever I'm discussing, you guys are okay with that. You are understanding. Okay, distribution of fossils. Distribution of fossils. See, distribution of fossils is very easy to understand. Correct. When identical species of plants and animals adapted to living on land or fresh air, they are found either side of the marine barriers. For example, what we're finding in North America, you could find same thing in the Africa. Okay, and there are some examples like Mesosaurus, a small reptile that used to be found in both the sides, Brazil and as well as in the African side. So all these things were there. Distribution of fossils also made something sure what Wegener was saying, that it was all together before, and it was supporting the continental drift theory by Alfred Wegener. Okay, what is the next point? Next point is force of drifting. Okay, this is an easy point to remember, because what Wegener suggested, that he said that it is moving. the continent is moving, it is going separated. So there should be a force behind to move, right? A static, a constant body will not move. There have to be something, a pushing factor to move. And this pushing factor was pole fleeing force and tidal force. Pole fleeing force and tidal force. So what do you mean by pole fleeing force? Pole fleeing force means towards the poles you are moving. Okay. This one will move towards this pole and this one will move towards this pole. Towards the force, poles you are, it's called pole fleeing force. And tidal force means it is actually due to the attraction of moon and the sun that develops tides in the oceanic waters. Okay. Because of that also it is moving. Okay. In detail, we can discuss later, but these 2 points, because if I'm talking about tidal force, I have to speak in detail about how moon is affecting the tides on the earth and how water is having high tide, low tide, all these things concept we have to decide. We have to discuss. Keeping this apart, we have to understand for time being that there was a force of drifting was also there. Okay. So these were the main points which Alfred Wegener have put in. And some scholars have considered all this is inadequate and not proper. And later on, when other studies, the post-drift studies has come, and all the studies have shown that, okay, somewhere he was correct and some points was correct. Okay, I'll repeat. We are talking about continental drift theory. And here we are discussing about evidences in support of continental drift. Okay. First thing, we talk about matching of continents like jigsaw fit. Second one, rocks of same age across oceans. Third one, there are tillite deposits. There were placer deposits. Distribution of fossils was there. Force of drifting was there. All these things actually played a very important role for Alfred Wegener to confirm that the continents was together at some point of time, and later on it got separated into the current situation, and now also it is moving, and after a few millions of years the situation will be different, world map will look different. Okay, that is what we discussed. Okay, next one, next we'll discuss what. Okay, we'll discuss about plate tectonic theory. Plate tectonics theory. Okay, I'll see if time permits, we can do. Plate tectonics theory. What is plate tectonics theory? See, first you should be knowing what is a plate. Okay, a tectonic plate. What is a tectonic plate? A tectonic plate or a plate is actually a lithospheric plate as a massive, like it looked like a slab. Okay, irregularly shaped, not fixed shape. It looks like a slab of solid rock, generally composed of both continental and oceanic lithosphere. Okay, so I'll write down here a tectonic plate also called lithospheric, in bracket you can write also called lithospheric plate, is a massive irregular or irregularly shaped slab of solid rock. This definition is directly from NCERT. Okay, so you can purely rely on this. Solid rock, generally composed of both continental and oceanic lithosphere. Okay, so a tectonic plate, also called a lithospheric plate, is a massive, irregularly shaped slab of solid rock, generally composed of both continental and oceanic lithosphere. Okay. See, these plates move horizontally over the Earth's surface. The lithosphere includes the crust and the top mantle. Okay, I'm talking about lithosphere here. Lithosphere includes crust plus top mantle. If the earth layers are here, you know that we have crust, mantle, core. Crust, mantle, core. Okay. A plate is this much. Okay. Crust and the upper mantle. Okay. This is about the plate. So a plate is a massive, irregularly shaped slab of solid rock, generally composed of both continental and oceanic lithosphere. Plates move horizontally over the Earth's surface. So lithosphere includes the crust and the top mantle. This much you understood. Okay. Now you see. See, this plate may be referred to as continental plate, or it can be called as oceanic plate, depending upon what is lying on top. For example, on a plate means a slab. Now you go to understand it's a slab kind of thing. So if on this plate, if water is on top, what will you say? Oceanic plate. If land is on top, what will you say? Continental plate. Anyway, it is moving. Okay. So this, for example, if Pacific Ocean is on the top, we say it as Pacific plate. And if Eurasia is there, Asia is there, we say it as a Eurasian or a continental plate. Okay, that's the difference. Okay, and there are a lot of major plates and minor plates, but you should be knowing what are the major plates. All this is important. Okay, let me write down 7 major plates. See, more than writing down, I think I can draw it. Okay, more than writing down like bullet points, it will be easy if I can locate it in a map and show it to you. Okay, easy. Let's start. India is here. This is Eurasian plate. Okay, that is Asia and Europe together. Okay, then we have Canada, US, Mexico. Which continent? North American plate. Okay, and under Eurasian plate, what do you have? You have Australia. And you have New Zealand here. Okay, fine. Then we have North America. Obviously, what will come next? Some joint, some formation is here. Sorry. South America. Okay, this is disastrous. Better. South America. South American plate. Okay. Then what comes? We have only African plate here. African plate. So we have Arctic here, we have Antarctic here. Antarctic plate. Okay. These are the major 7 plates. Okay. I'll repeat, Antarctica and the surrounding ocean plate. This is the plate number 1, Antarctic plate. Okay, because questions come directly in test series and in prelims. That some MCQ something like what are the major plates? Okay, select the major plates or select the minor plates. Okay, all these things. Minor plates, it is impossible to remember everything, but 3-4 you should be remembering. But major plates at any cost you should be knowing. Okay, so Antarctica and the surrounding oceanic plate is the one thing. Second one is North American plate. Okay, North American plate. And third one is South American plate. Fourth one is Pacific plate. Okay, Pacific plate is the oceanic plate, and Pacific plate you can mark here. Pacific Ocean. Pacific plate. So don't think that only land mass we are measuring. We are also taking the oceans. Okay. Pacific plate. And then we have India, Australia, New Zealand plate here. Fourth one, and fifth one. Okay, this is 4. This is 5. Okay, and sixth one is African plate, and seventh one is Eurasia and the adjacent oceanic plate. These are the 7 important oceanic plates. Okay. In mains, when you are writing, make a rough sketch of global map or world map. You can fetch very good marks. See, by drawing this much, at least you got an idea, no? So it is like this. So it is easy that you don't have to be very perfect, picture perfect in drawing all these things. And in Google, if you type and you can see that how to draw Indian map in 1 minute 30 seconds, you will get all these techniques. Okay, you can do all those things. Okay, nevertheless, let's go ahead. We are talking about plate tectonics. I told you plate is lithospheric plate. It consists of crust at the upper mantle. There are 7 major plates. The 7 major plates are Antarctica, North America, South America, Pacific plate, Australian plate, Eurasian plate, African plate. So 7 different plates. Okay. Now you should be also knowing some minor plates. Okay. Minor plates means the area is very less. Although all the plates are moving, the importance of the area covered is very less. Okay. That is there. Okay. Minor plates are, we have Cocos plate, we have Nazca plate, Arabian plate, Philippine plate, all these plates are there. This 4 I'll try to map. Okay, I'll try to map anyway. Let's continue. Minor one I'll map in blue. Okay. Central, this is Cocos plate is between Central America and Pacific plate. Okay. Something here. Cocos plate. Central America here. Okay. Cocos plate, minor plate. Then we have Nazca plate, that is between South America and the Pacific plate. Okay, here. NAZCA, Nazca plate. Okay, then we have Arabian plate here. This side it will come. Arabian plate, where Middle East countries are there. Okay, then we have Philippines plate. Where will Philippines will come? Here. Philippines plate. These are the 4 minor plates that you should be remembering. Okay, then other plates are also like Fuji plate, Caroline plate, all these plates are there, but not that important. You should be knowing all this 7 major plates, at least 4 minor plates. Okay, I hope this is clear. Now I want to discuss about plate boundaries also. Okay, because we are discussing about plate, let's discuss about plate boundaries also. Plate boundaries. There are 3 different types of plate boundaries are there. Divergent boundary. Second one, convergent boundary. Third one, transform boundary. So what is divergent boundaries? When divergent boundary means actually spreading sides. Okay, these plates are actually spreading like this. It is moving away. Diverging apart. This is called divergent boundary. Okay, and we have an example here. We have Mid-Atlantic Ridge. I'll show you where is Mid-Atlantic Ridge. Okay, you can see here. Between North America and Eurasian plate, we have Pacific Ocean. Okay, Atlantic Ocean is here. Okay, you have something called a Mid-Atlantic Ridge passing through this area. Here, what is happening? The plates are diverging. That means space is coming in between. That means Atlantic Ocean is expanding. Ring of fire is there in Pacific Ocean. Okay, here, this area we have ring of fire. Okay, I'm talking about Atlantic Ocean. Here, we have divergent boundaries. Okay. Let's go back. Okay, example. Mid-Atlantic ridge. Okay. Next, we have convergent boundaries. Convergent boundary means this convergent is coming together. Okay. Convergent boundaries are when maybe a continent or a continent coming together, ocean or ocean coming together. We can write an example here. Mount Everest. That area, that is Indian plate is coinciding with Eurasian plate. It is like mountains are. See, that may be because of the action of volcanic eruptions. Okay, that is a different thing. Because in at mid-Atlantic ridges, I told you there are a lot of volcanic mountains forming. Because of that, again, see, mountains will happen both in divergent boundaries and convergent boundaries. Divergent boundaries are like this when you're going apart. Okay, that time space will happen. Because of that, here volcanic eruption happen and mountains will form. And convergent boundary means both coming together. When it is coming together again, this is actually pressed and then Mount Everest is formed like this. Okay, like pushed and then formed fold mountains, and this is how it is formed. And here you will get block mountains. Okay, there's a different perspective all about to talk about, but no problem. So convergent boundary means converging together. Okay, we can say that Mount Everest height is still increasing. It will increase. It is not like stopped. Process is not stopped. It is increasing day by day. Okay. Then we have transform boundary. Transform boundary means it is like this. Vertically moving up and down. It actually causes a lot of earthquakes, etc. Okay. See, you have to remember only these three things. What is divergent, convergent, and transform boundaries? Divergent boundary means separating apart. Plates are moving apart. Okay. Convergent boundary means plates are coming together, and transform boundary means plates are going. Neither that nothing is produced there. Okay. Not destroyed in transform boundary. The plates slide horizontally past each other. Transform faults are the planes actually separation generally perpendicular to the middle oceanic ridges. It is like moving like this. Okay, like moving perpendicular up and down in a vertical position. Nothing is produced or nothing is destroyed here. Okay, but a lot of earthquakes happen because of this transform boundaries. Okay, any doubt you can ask. Otherwise, we are done. All the best for your test series. Whatever topics I have taken, I think I have covered everything in that. Even though you have taken little time, but whatever concept I should give you, I've given you. Okay. Thank you so much. Bye.